Hello class, so we're going to be looking at u substitution continually. Here, so as you can see, if you can set u as 1 plus e to the x, then you get to realize that the u becomes simply derivative of this, which is e to the x, dx. I'm multiplying by dx on both sides. Now, you can see that this portion, these two comes together, becomes du, and this becomes integral of square root of u and du. Since that can be rewritten as u to the 1/2 power du, then what we end up getting is u to the 3 over 2 power over 3 over 2 plus c. If I have to rewrite this one, yes, we will end up getting 2 to the u, in this case, which was 1 plus e to the x power, holding to the 3 over 2 power over 3 plus c. That becomes our final answer. Alright, number 26. Here, that's right. If you set cosine t as u, then du is equal to negative sine t dt. And here, sine t dt, that's what we have, so therefore we get to realize negative du is equal to sine t dt. And we end up getting, because of the negative sign, I'm just going to put the negative sign way in the front, and we end up getting e to the u, and then du. That's what we end up getting. And this simply becomes negative e to the u plus c, because antiderivative of e to the u is simply e to the u. And then here what we end up getting, yes, negative e to the cosine t plus c becomes our final answer. Alright, number 27. Yes, that's right. If you set 1 plus z to the third power, as we take the derivative, it becomes second power. So as you can see, u can be equal to 1 plus z to the third power. Now then du becomes 3z squared and then dz. Now as you can see, we don't have 3 in the front, so what we can do is we can divide by 3 on both sides. And what we end up getting here is that z squared dz, these two things come together, becomes du over 3. So what I'm going to do is I'm going to simply put du and then 1/3 in the front. Now cube root of u was the inside value. If I were to rewrite this one, I'll end up getting 1/3 and u to the 1/3 power and du. Now taking the antiderivative, we end up having 1/3 times u to the 4/3 over 4/3 plus c. Now, then what we end up getting here is that 1 over 4 when you combine these two things together, and in place of u we have 1 plus z to the third power, the 4 over 3 power. Notice this 3 and these two 3's, they don't cancel out because of the 1. We have two terms. Plus c becomes our final answer. Alright, how about this? Yes. If you set u as arctangent of x, then du simply becomes 1 over 1 plus x squared dx. Then this becomes rather simple. Becomes u du. Because the whole bottom portion with dx, that becomes the du. And what we end up getting here is u squared over 2 plus c, where u becomes inverse tangent or arctangent of x, the entire thing squared over 2 plus c. Alright, here we have same strategy. Tangent x can be u, then what we end up getting is the u becomes secant square x dx, and that's exactly what we have over here. So therefore this becomes e to the u du. Now this becomes e to the u plus c simply. And what we end up getting is u was since tangent. Our final answer becomes e to the tangent of x plus c. Alright, number 30. What should be the value of what should be u? Yes, it has to be ln of x. If you set that up as u, we end up getting the u becomes 1 over x, which is a derivative of ln of x, and simply multiplying that by dx. In other words, this becomes our du. So our new expression is sine of u du. Now, of course, antiderivative of sine becomes negative cosine of u plus c. Now, since u is equal to ln of x, then what we end up getting is negative cosine of ln of x plus c. That becomes our final answer. Number 31. Now, when you look at number 31, it looks somewhat complicated. Now, you can consider this one as that u equals to sine of x, and we end up getting the u becomes cosine of x dx, but that's what we exactly get to see over here. So therefore, this can be rewritten as 1 over u squared du. Then what does that become? Yes, it does become negative u to the negative 1 power plus c. Now, then we change up being negative sine to the sine x to the negative 1 power plus c, which simplifies into negative cosecant x plus c. Now, I'm not sure if you noticed it or not. Second way to do this question would have been this. This can be broken into cosine of x over sine of x times sine of x dx. Then once you look into this one, this becomes, yes, it becomes cotangent of x times, this becomes, yes, cosecant of x dx. Now, when you take the antiderivative, yes, it does become that right away, because derivative of cosecant is the negative cosecant and cotangent, and we get to see that right away there. Number 32. Yes, we can set u as the bottom e to the x plus 1. Then what we end up getting is the u becomes simply e to the x dx. And that's exactly what we have here. So this becomes 1 over u du. And here we end up getting ln of u plus c. But since u is this expression, we end up getting ln of e to the x plus 1 plus c. All right, let us move on to the next question, number 33. Which one? That's right. Cotangent is what we're looking for. If you said u as cotangent of x, then the u becomes negative cosecant square x dx. And we have everything except the negative sign. Then negative du is equal to cosecant square x dx. That means when you put this one in, what we end up getting is negative because of the negative sign in the way in the beginning, and then square root of u du. Now, what does that mean? It's simply negative e to the 3 over 2 power over 3 over 2 plus c. Now, this simplifies into negative 2/3, and since u was cotangent of x to the 3 over 2 power plus c. Alright, now let us look at number 34. Here, what should we have u as? Yes, in fact, if you consider pi over x, if you set u as that value, then du becomes negative pi over x squared dx. And except negative pi, so we're going to divide each one by negative pi, because that's what we don't see. We end up getting 1 over x squared dx. That's exactly what we see over here. So if you have to substitute everything in, we end up getting cosine of u and du with 1 over negative pi in the front because of this factor. Now, then this becomes negative 1 over pi times sine of u plus c. But u here in this case becomes pi over x, so what we end up getting is negative 1 over pi times sine of pi over x plus c. Alright, number 35, so let's look at it. Which one would be a good expression, in fact. So now, when you look into sine of 2x over 1 plus cosine square x, let us assume about denominator here. We end up getting u equals 1 plus cosine square x. Then du becomes 2 cosine x. And then by the chain rule, we will end up getting negative sine of x and again dx. But in fact, if you think about this one, 2 cosine x sine x, this in fact becomes sine of 2x, as you can see over here. So therefore, if you have to rewrite this one, du is equal to negative sine of 2x dx. And with the negative sign going over to the other side, we end up getting negative du must be equal to sine of 2x dx. And now this can be rewritten as negative by this negative sign, 1 over u du, and this becomes negative ln of u plus c. Now this becomes negative ln of, in place of u, we're going to have 1 plus cosine square x plus c. Alright, number 36. This question looks very similar to the previous question, number 35, except that we don't have 2 over here. Now, so therefore, if you make the entire denominator as the u, then we will not be able to do the same thing as the previous question. And what can we do? What if we set u as cosine of x? Then we end up getting du becomes negative sine of x dx. Now, putting the negative sign to the other side, we end up getting negative du is equal to sine of x dx. Now, if you have to rewrite this one, then we end up getting negative sine x dx becomes du, and 1 over, denominator becomes 1 plus u squared. Now, this one looks somewhat familiar. Yes, this is the arctangent, derivative of arctangent. So we end up getting negative arctangent of u plus c. Now, since u is equal to cosine of x, we end up getting negative arctangent of cosine of x plus c. Alright, let us move on. We have cotangent. What are we going to do? If you have to rewrite this one, cotangent as cosine of x over sine of x dx. Now, from here, if you said u as sine of x, then du is equal to cosine of x dx. Now, if you have to use that, then we end up getting 1 over u du, which ends up in ln over u plus c. Now, ln of u in this case was sine x plus c. So to the potential negative values of sine of x, we put the absolute value to prevent that. Alright, let us look at number 38. Here, how are we going to do this? In fact, if you have to rewrite this one, we'll end up getting something quite nice. Cosine square, if you have to rewrite this one, would be equal to secant square x square t dt over square root of 1 plus tangent t. Then this becomes somewhat nice, because if you said u is equal to 1 plus tangent t, then du is equal to, that's right, secant squared t dt. Then this can be rewritten as 1 over square root of u du. Obviously, this becomes u to the 1/2 power over 1/2 plus c. Then this simplifies to 2 times square root of, since u is 1 over 1 plus tangent of t plus c becomes our final answer. Alright, number 39. How about this one? That's right. The fact that we have secant cube and tangent, and if you remember, if you said u as secant x, then du in fact becomes secant x tangent x dx. In other words, this we can rewrite this one as secant square x, and having one of the secant with the tangent, to become secant x tangent x dx. Now then, this will be already easier for us to plug things in, because here we end up having, in place of secant, we could have u squared, and the other secant and tangent becomes du. So it becomes u to the 3rd over 3 plus c, which ends up being secant cube x over 3 plus c. That becomes our final answer. Alright, let's look into this one. Now, what's going to be happening? Yes, that's right. If you consider cosine t right over here inside as u, then du becomes negative sine t dt. Then I can rewrite this one as, with the negative sign going over to the other side, so negative secant square of u du. Then this becomes negative tangent u plus c, where u, since u is equal to cotangent of t, this becomes negative tangent of, or cosine of t plus c. That's what we end up getting, number 41. Now, in this case, if you set this one inside of the radical as u, then you have no place to find du. But in that, on the other hand, if you set u as arc sine of x, then we end up getting du is equal to 1 over square root of 1 minus x squared dx. And we see that, but resembling that over here as part of the u. So this becomes integral of 1 over u and then du, which is equal to ln of u plus c. Since u equals arc sine of x, so we end up getting ln of arc sine of x plus c. That becomes our final answer. Alright, a couple more questions. So now we have number 42, x over 1 plus x to the fourth power dx. Now, if you consider the whole entire denominator as the u, then we would be needing x to the third power. So therefore, the fact that we have a linear term here, that means one thing that which we can do is this. What if we let u as x squared? Then we end up getting du is equal to 2x dx. By dividing it, we end up getting du over 2 is equal to x dx. So here we can rewrite this one as 1/2 with the coefficient and 1 over 1 plus. Since x squared is u, then this becomes u squared and du. Now, this one should look somewhat familiar because, yes, that's right. That's equal to arctangent. Arctangent of u plus c. Since u equals x squared, we end up getting 1/2 arctangent of x squared plus c. Alright, let us move on to the next question, number 43. Now here, what are we going to do? Okay. So here, when we have 1 plus x squared, it's somewhat quite challenging. But if you were to put this one into this way, that as a 1 fraction, and this one, red one as another fraction, then this might be somewhat easier to look at. So here we have 1 over 1 plus x squared plus x over 1 plus x squared dx. Then of course this becomes arctangent of x. Now to do this one, what's going to be happening is this. Set u equal to 1 plus x squared, and du becomes 2x dx. Therefore, du over 2 becomes x dx. Now, that means this becomes integration of 1/2. I'm talking about this one alone. Becomes 1 over u du. then becomes 1 half ln of u plus c, which finalizes into 1 half ln of u, because u was 1 plus x squared, 1 plus x squared plus c. Now bring that up over here, then we end up getting plus 1 half ln of 1 plus x squared, and in time being plus c. That whole thing becomes our answer. Alright, number 44. Here, how would we be able to take the integration of this one? So in this case, we don't see the u and then its derivative directly. Let us try to assume that maybe u is equal to, same as before, 1 minus x. Then in fact, how are we going to calculate this one? Yes, x. Then x becomes 1 minus u. So therefore, if you have to consider this one, then this can be rewritten as this. X squared, that means 1 minus u squared all over square root of u. And then taking the derivative on each side, du becomes negative dx. So I'm going to put du, and then we're just going to put the negative sign in the front. And if you have to rewrite this one, what's good about this is that we have 1 minus 2u plus u squared. The entire thing divided by square root of u. du. Now, then that becomes negative. This becomes 1 over square root of u minus u divided by radical u becomes 2 radical u plus here the last term, which we end up getting u to the 3 over 2 power du. Then what is this equal to? Negative. Here we end up getting, since this one was u to the negative 1 power, so we're going to have u to the 1 half power divided by 1 half. And minus here 2 times u to the 3 over 2 power divided by 3 over 2. And then plus, here we have u to the 5 over 2 power over 5 over 2. Therefore, plus c. Then if you have to rewrite all these things down, then what we end up getting is this. Since u is equal to 1 minus x, the first term with the highest exponent becomes 2 over 5 to the 5 times 1 minus x to the 5 over 2 power minus 4 over 3 to the times u to the u. Since u is equal to 1 minus x, so 3 over 2 power. Last one is here. Minus 2 times 1 minus x to the 1 half power plus c. Alright, let us look at the next question. Here we have u. If you consider u same way as before plus 2, then we end up getting du is equal to dx. That's not a problem. Well, another thing is then x is equal to here u minus 2. So what we end up getting here is that this becomes u minus 2 on top all over u to the 1/4 power and du. Then this becomes, first term becomes u to the 3/4 minus 2 times u to the negative 1/4 power du. And this becomes, yes, u to the 7/4 power over 7/4. And then here it becomes, that's right, minus 2 u to the 3/4 power divided by 3/4 plus c. And this simply means 4 times u, which is x plus 2, to the 7/4 power, whole thing divided by 7, minus 8/3 x plus 2 to the 3/4 power plus c. Alright, so the next question here, the last question, and here what we're going to have. So square root of x cubed, and then all these other things. So if you have to consider maybe u as x squared plus 1, and we end up getting du is equal to 2x plus 1, and 2x, not plus, simply dx. And since we only have x, then x is equal to x dx is equal to du over 2. Then if you have to start to put everything in, I'm going to just simply separate x into x to the 3rd power as x times x squared, square root of x squared plus 1 dx. Now with x dx, it becomes du. So what we end up getting is this: x squared is equal to u minus 1 times this one becomes square root of u du. Here then we end up having u to the 3/2 power minus u to the 1/2 power du. Now then this becomes rather simple, because we u to the 5/2 power divided by 5/2 minus u to the 3/2 power over 3/2 plus c. Then this simplifies into 2u is x squared plus 1 over 5/2, entire thing over 5, minus 2 can come to the front, similar idea, x squared plus 1 over 3 with the exponent of 3/2. The last one is simply plus c. Alright, that's it. Have a nice day, guys. See you guys later. Bye-bye.